All right, we are live. Let me start sharing my screen and then you can go from there on. Can everyone see my screen?
I can see it, Robbie.
Yep, no problem.
All right. So the today's session that we are going to have. Welcome everyone to the HPC user session first. So today we are going to be talking about running your jobs in parallel, specifically array jobs. That is, they are jobs that have similar type to, or they are the same type of jobs that you're trying to run on different subjects. We'll go a bit more into detail of what those types of jobs are when we are going through our session. Uh, but eventually, I mean, so the first variation that you can have over those multiple jobs is subjects. And then the variation that you can have is the number of, or the types of parameters that you can pass with those jobs, or the value of the parameters, different parameters for that job. So we are going to discuss all that, and after that, William is going to show how you can use Python to generate SBAT scripts that can, where if you have varying parameters that you want to use or set up, then you can use that Python script to actually run, create and submit all those SBAT jobs. And so today we are going to be concentrating on the bash array jobs, and this is the tutorial which we created that's going to be helpful in talking about this. Let me post the link in chat. And feel free to stop me at any point during the session if you guys have any questions. And we generally like to, actually wait, I sent it to everyone in waiting room. Where is the everyone's option?
There should be in the chat window, there should be a 2-line. Near where you would type the message, at least in principle. Do you have your screen maximized? If your screen's maximized, unmaximize it. I think the interface is a little cleaner.
Oh.
Why don't I paste in chat and you can continue?
yeah, that works. I posted the link in the chat, so you guys should be able to use that link to come to this Git repo. This is kind of a practical repo, so you can try to do this stuff right now as well. But I'm just going to talk through them, and then we are going to and mention how you can use this repo further on to get a better understanding of array jobs. So we'll go to the bash array jobs folder within this bash tutorial parallelism repo. So let's start. So the scenario for using array jobs is that one user needs to submit a very huge number of jobs, very similar jobs on the cluster, but for different subjects. So suppose you are running, as an example, I don't know, what's that, DICOM to Nifty script that you are trying to run. I'm not sure how many people are familiar with that over here in the users today, but it's basically just take any executable that you want to. But you want to run that executable over multiple subjects. So for running it over one subject, you can just create a normal job script. If you are not familiar with Slurm job scripts, if you just search for Chiha Slurm, that would be the first link that comes up. Go to Slurm, and then there is this example batch job script. So you have an example batch job script, you create this, you run dicom to Nifty and the dicom file over here that basically just converts the dicom file to Nifty file. And you're done. You just submit this job and you're done with one subject. But what happens if rather than just having one subject, I have, I don't know, 1,000 subjects that I want to do? One method is a manual process. I mean, it's like the most basic approach that you can think of. You have created one example job script, you copy it over to the next job script, or copy it and create a new
Ravi,
job script.
sorry for interrupting. Can I record the session, please?
So this one is streaming on YouTube. So you should be able to, let me see.
It's going to be there after we finish.
Yeah, it should be available after I finish. Let me post that in chat as well.
Thank you.
Here is chat. All right. So, like I was mentioning, first one is a simple manual process or very basic manual process. It's a lot of manual work and really time consuming. You are creating a copy of your original job script, and then you are just changing the subject on which your job script is acting on.
Not to
And
mention now you've got 1,000 job
yeah,
script files.
yeah. So you have 1,000 job script files. You will have 1,000 output files that Slurm is going to create, and then the and uh, and basically, yeah. So it's going to be a hassle to work on. First of all, just creating all those job scripts is going to be a real pain. So what's a little smarter method of doing the same thing? We can use bash scripting, right? I'm guessing all of you guys would be familiar with for loops and how you can just run a for loop over and over again over the same thing, create the batch script, and then submit that. That's what's happening over here. So for example, if in this data dir we had all the 1,000 subjects, then we can just use this for loop. So for file name in this data dir, we do whatever is mentioned over here. And then we just, so however many files are present in this data dir, this for loop is going to keep repeating. So what you can do is you can ask your bash script to create a job script over here, and then ask your executable line to be acting on a new file every time. So this is going to be faster, or way less time consuming. There are some problems with this though. So the first problem is it's great for a small number of files. It's basically if you have 20-ish files or something, right? And then it's great. If you have 1,000, like in our example, you this bash script is not going to work very well because the Slurm scheduler has to keep track of all the job script. It needs to keep that in memory and then submit them at the time when the job goes from pending to running state. So having all these files in the Slurm database or the Slurm scheduler's memory, it's going to overwhelm the Slurm scheduler. And what's going to happen is the Slurm scheduler is going to crash or it's going to become really laggy for
So
some time.
please don't do this for 1,000 files.
Yes.
Yeah.
Yes. I mean, if you have 20 at a stretch, let's say 30, 40 subjects on which you are trying to do this,
Yeah, that's reasonable.
this should work. Yeah, that's reasonable. If you go above 40, just we are going to get to the next stage, the array jobs. That's what we should do if we have a large number of subjects. And the second issue problem that hasn't been mentioned over here is that that also means that you have to learn more of bash scripting. You have to learn how you can run the for loop. We have given an example over here, so it's not very, very difficult, but it is still something that you'll have to learn a bit. So you need to know how to create a job script over here, and you can find an bash parallel script example in this repo. So if you just click on this, this gives you how you can use this to create the scenario that we were just discussing, where your bash script is generating all the your jobs files and submitting it. But like we mentioned, anything above 40, don't use bash scripting as well. That's where array jobs come into place. So we have discussed that a folder has 1,000 files. There are two ways that folder can be structured. So the first one is uh, the first method is either the file name can be sequential. When I say sequential, I basically just mean that uh, you have a, you have a so your subject names are basically like subject 001, subject 002, subject 003 till subject 1000, right? So that's one way your subject's name could be, or the other one is random. Let's take a look what happens if your file names are sequential. That is, they have a sequence attached to it. What we'll do is we are going to make use of that sequence named initially. So what happens is it's a normal batch script. If you guys are familiar with batch scripts, apart from one small change, that you are also going to specify dash dash array equal to 1 to 5. And then in the job name, basically you don't need to keep these. This is useful if you want to, I guess, differentiate between what you're trying to do. Plus you should definitely try to use this percentage a uppercase a and percentage lowercase a in your error and output file, so that uh, multiple of your runs are not collectively being I don't know, piped out to one single file. So you don't want all of your 1,000 subjects, whatever is happening over there, everything to go into one file, because you would not be able to differentiate between that. So if you run into error in any one of these, in any one of the subjects, it would be very difficult to debug what happened in that job.
Right.
So
you can have the error and the output files be the same too for a given job if you want.
yes.
And then that way your command line output will look just like it would at the terminal, for example.
Yeah.
Or you can have them in separate files like here. That's fine.
Yeah. And so the percentage uppercase A is the job ID. So every time you submit a job, your job script gets, your job submission gets assigned a job ID. And in array jobs, you also get assigned an array index of the job. So what this basically does is it's going to submit 5 jobs. All 5 of them are going to have the same job ID, but all 5 of them are going to have separate uh, array index. I mean, it's going to be the same job ID for you as a user. For Slurm, they all are 5 different jobs. And basically what is going to happen is, suppose your job ID was 5, let's say. So what's going to happen is the first job that gets submitted over here is going to have the job name as test underscore job underscore 5 underscore 1. Then 5 underscore 2, the second one, then 5 underscore 3, and so on and so forth. How you can differentiate between, so you are submitting 5 jobs. How do you make sure that all the 5 jobs are acting on different subjects over here? That's where we make use of this $slurm array task ID environment variable. So what we are doing is actually, it might be useful if I'm also running this, I guess. So I'm guessing you guys are familiar with on-demand portal. You can actually just go and get a terminal access right here. All right. User. Oh, I already have tutorial. All right. So what we'll do is we are just going to run this. So we want our prep env to be sequential. So what this basically this command does is it creates a tester. So change directory to tester, or actually just ls tester. Actually, let me clean the environment first.
Yeah, we gotta do it again, I think, right?
Yeah. Cleaner basically just gets you into a pristine stage into this git repo so that you can just start everything again. So what we are going to do is we are going to create now there should be another tester, and this is what I mean by sequential. So we have different subjects over here, but each of them has a sequence. So I have test 1, test 2, test 3, test 4, test 5. So 1, 2, 3, 4, 5, they all are sequences, right? So that's what basically sequential means. So what would happen over here? It's basically going to test. Yeah, so it's just going to create these files and all of them are going to have this line. So processing file test 1, processing file test 2. This basically shows that you, with each job or each of these 5 jobs, you are creating different jobs and all of them are acting on 5 different files. So let's try to submit this. S batch array sequential jobs. So you'll see, so the job ID remains same, but you have this 1 to 5. All of them are in pending state right now. And
Yep,
you'll see
there we
once
are.
all starts, they all come out as these jobs. So say _1, _2, _3, _4, _5. And I think I sleep for some time just so that I can show that it's running. I think it's 30 seconds that we sleep for. So
Yeah, it's 30 seconds. Do you want to talk about the percent modifier for the array flag too?
Which one?
So after 1-5, you can put percent and then a number, and it will cap the number of simultaneous jobs to that.
Yeah. So basically what happens is these jobs are done. So just before, let me show them this. So if you see, this is what we were echoing in. So processing file test 1. And if you wanted to go to, let's say, test 4, it would be processing file test 4. So all of them are processing on different files right now. So what William was mentioning over here is, let's say we wanted to, so we are submitting all the 5 array jobs, but we just want only 3 to run at a time. The reason why you might want to do that is, let's say you have those 1,000 subjects and all of them are using one core, right? Slurm is going to limit you on its own because we have set some limits that a user can only use 260 or 300 cores at a time. So after those 300 cores, rest are going to remain in pending without your intervention or something. But what would happen is, once it has used all those 300 cores from your allocation, you don't have access to any other core to do any other work. So suppose you just wanted to, I don't know, work on the next part of your workflow. And so for that and you need an interactive job for that, but you have already used up all your cores. That means you can't get an interactive job. So you might want to limit your array jobs to, let's say, 200 cores. So you have about 60 or 100 cores remaining for other kind of jobs that you want to do. How you can achieve that in an array job is basically just what you'll do is just add with this dash array, you can just type in 3, percentage 3. What this is going to do is it's just going to run 3 jobs at a time.
You want to show?
Yeah. Let's submit them.
Yep. Yeah, it may take a
All
second.
right. So they all are in pending.
Well, eventually.
All
There
right.
you go. See. Yeah.
So you'll see earlier when we were trying it, all 5 jobs started at a time, but right now only 3 jobs have started because we specified that only 3 jobs should run at a time. And once these jobs have finished, we'll see once the 30 seconds are up that the next 2 jobs, 4 and 5, are going to start.
Is there a built-in limit for that? I'm not sure. I haven't checked myself.
Oh yeah, I haven't checked in it either. I mean, array jobs, I think there is like 10,000 jobs that you can submit at once or something. I think that's the limit. But yeah, I mean, if you guys are going above 1,000 array jobs, let us know and we can find that limit for you and give a really confirm what's that number. Let's see. So 1, 2, 3 are finished, and this 4 and 5 should start soon. Yeah, and so now 4 and 5 are running as well.
Yeah, it looks like there's a configurable value, but I don't know what that is. We probably have it set at the.
Yeah.
Mike has that set to something reasonable.
All right, and let's take a look at, I guess, another test 4. So this is the second one that ran. Test 3, this also has 2 now.
And that's because you appended to the file rather than overwriting.
Yeah, and so we are just going to clean the environment again because we have tested out all the sequential array jobs. And then we can come on to the random file names. So not every time you are going to have the sequential file names, right? You're not going to always have test 1, test 2, test 3, test 4, test 5. You can have your subject names really, really random. I mean, it might be because you have tried to anonymize everything. So you have given random values to each subject, or for any other reason you have random file names.
Or it's just not sequential. It might just have multidimensional data.
Yeah,
Right.
yeah. And so what happens in that case? It's simple enough. What you do is we create an bash array and then, or shell array, and then we define the file name based out of that array. And again, we are using $slurm array task ID. So what's happening is, suppose your data dir is this tester that we just created, right? And then you create a shell array that's basically lists all the things in this data dir or this test dir into this variable. And then file name is where we define that from this array, I want whatever is the value over here. One change that you will notice is that the array moves from 1 to 5 to 0 to 4. This happens because shell array starts from 0 index rather than 1 index. So to show you an example of how this will work, I think I mentioned, yeah, files is a shell array which contains all the file names from data dir. File name is assigned the corresponding index from files array. All right, so let's see. So dot, and now if we take a look at tester, rather than a really nice test 1, test 2, test 3, test 4, we have these are our subjects now. We still want to perform the functions as is, like we had in the sequential, but we know that we can't just use this function directly because there is no nice I guess structure to your data right now or to your file names. So we are going to just try to submit this job now with the array random.job. So sbatch again, this should start all 4 of them or all 5 of them because we haven't set a limit of how many should run right now.
Yep.
And so let's test let's take a look at this one. and you'll see that it is processing file. So ultimately we are doing the same thing. It's just if it is a random name, we had to add some additional steps over here. Because we could not use the file structure very smoothly, so we had to create our own array, and then from there we are finding out the correct values and uh, working on them. And I think I've already shown all the content of this Git repo, what's prepenv, cleanenv. But if you guys are going through this in your own Chiha shell environment, I think this section is going to be useful as well. One other thing that I would mention is what if you have jobs with parameters. So there are two methods, or I'm going to mention one method over here. Either you can have all the parameters in a list or in a file, like you have a CSV file where you can define all the different parameters. If you have, in that case, you can use any of these two, array job with parameters 1 or array job with parameters 2. These are two different, let's say, algorithms to achieve the same thing. So you have a CSV file where you have defined what your parameters should be, and then these algorithms are going to go in and try to figure out what those parameters are. So let's take a look at one of them. Array is 0 to 2, again because we'll have to create some of our own uh, shell arrays, so that's why everything will start from 0. And all of the other things you're already familiar with. So what's happening over here is we have test.txt. I'm not sure if we have test.txt in this. No, we didn't. So what this basically doing is you have a test.txt file where you have 3 rows. The first row is the values for a parameter called flow cell. The second one is for Hive, and the third one is for sample. So that's test.txt with 3 different columns. Now what we are doing is we are creating 3 different shell arrays over here, and basically everything in the first column is going into flow cell, and the second column is going into Hive, and the third column is going into the sample shell arrays. And then we are just echoing out different values. If you were trying to run some function over here, you could have just been like, this is the executable and these are the values that are available, use these and submit the array job. And the second method of doing this is so the second method is you just define both of those lists, so t.list and t2.list, and or you have 2 different files for different parameters. So the first parameter's values are in one file, the second parameter values are in the second file. What you can do is you can use sed to actually find out the correct value from those files. This one is a bit trickier to understand if you are not very familiar with Linux, I would say, since you are using set functions over here, and it's 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 simple enough to understand if you just basically see. So it's asking it to run this function on $a. $a is the t.list that we have over here. What it's asking is, I just want the first element from the file and in this file, and that's how you're getting the first element or 0th element. Then in the second one, this value would be 2, and again from the same file, just give me the second parameter value. And that's how this one is acting.
Right, and then the Slurm array task ID gives you the line, right?
Yeah. Slurm array task ID is giving me the line from which, or the row number from which I need to pick out the values. And so that's basically it from my side. Did you guys have any questions before I turn it over to William for his Python script demo on how you can use the same thing, having different parameters for your job, and how you can achieve that using your a Python script? Um, All right, I'll turn it over to you, William, then.
All right. I'm gonna share the screen here. I guess I'll stop. No. Can everyone see my screen okay?
Okay.
We're good? All right,
Yep.
great. Okay. So yeah, building on what Robbie was talking about, suppose you have some black box program and you want to figure out, well, if I use this configuration of parameters and this configuration of parameters, what are my outputs? And then you want to do, say, like a design of experiments, full factorial on that, right? And so let's say you have 100, 20 parameters and you've got 3 different kinds for each. And I know that's just a gigantic number, but you get the idea. You've got some huge number of possible combinations and you want to run them all, or some subset, right? Well, we've already gone over how you can do sequential jobs or jobs with different file names or things like that. But if you've got this multidimensional space that you want to look into, well, you might want something a little more intricate. So I've got this nice black box program here. Well, it's a white box for us, right? We can see right inside. So all it does is it just takes the list of parameters passed to it and says, I'm running those, sleeps for 5 seconds, and then says, okay, I'm done. That's our program, right? So if we want to run that, there's this really cool built-in package in Python for combinatorial stuff for making combinations of things. It's called itertools, and it's a lovely built-in package I use all the time for this kind of stuff, and it really simplifies this process. So we've got to write some boilerplate code first. So I'm going to show you. So we have to have this payload script. All it does is it takes in another script, right? Some design of experiment CXV, which we're going to generate in a minute, right? And the Slurm array task ID. And it runs this with a line from this with this particular line, like we talked about with Robbie's last example, right? And this is that script. I'm not going to go through it in detail, but basically it uses this lovely sub process to run the process with those arguments in a space separated list. That's it. It takes in a comma separated list, right? We're taking a line, replacing the commas with spaces, which Bash likes, right? It likes spaces, not commas. That's how it separates things. And then we just join it all together and run it as a process. So when we run it, it looks something like, blackbox.shell space parameter 1 space parameter 2 space and so on. And that's what it's going to run. Okay. And so that's all this boilerplate does. You don't need to worry about the details of it right this second, but I will post a link in the chat here for my repo if you want to play around with it or tear it apart yourself. One second. Where's my chat window go? Oh, there it is. Sorry, I moved way over here. Where is my chat? There's my chat. Okay. All right, there we go. So that's my repo for this. Okay. So now that we know how we're going to do this, we're going to run. So to reiterate, this is our payload, right? It loads Anaconda, loads our environment for this black box for Python, right? And then it calls Python, this payload function on this, has all the parameters from each line in turn to that thing, right? And so I'm going to show you what this looks like in a minute once we've generated it. So to do that, this is where the cool part comes in. This is my favorite part. We have this itertools package, right? And so all it's going to do is if we have some number of parameters and some version of each of those parameters, which I'll show you now, right? So I come from a machine learning background, whereas Ravi comes from more the bio background, right? So I'm going to show you this in a machine learning perspective. So say we want to do hyperparameter optimization, right? We have some learning rate, and we can say, well, we want to try it with 1/10,000th, 100th, and 1. And we want to try batch size. We want to iterate over 10, 30, 100. We've got some activation functions. We want to try different activation functions. We've got rectilinear unit. We've got tanh, and we've got sigmoid, right? And so we want to see, well, if we combine these in different ways, how much better can we do? Like, where is our best combination of hyperparameters, right? And so we need to run every combination. So in this SBatch job, well, this is where we generate the SBatch job. Should look pretty familiar, right? Hash SBatch, number of tasks, CPU per task, and so forth. And this is where the array part comes in, right? We're going from 1 to some number of combinations, and we're going to run, in this case, hard-coded 4 at a time, right? Mm-hmm. There's that % 4 at a time. We'll go on this. Okay. So let's get to the actual generation. Okay. So we take in this file. This is what we're going to be taking in, this file, right? And so when we first bring it in, it's going to look something like, we're gonna take it and we're gonna make pairs, right? So the name and each element, right? And so we're gonna make a list of lists. This is our outer list, and so it's gonna look something like this, right? Learning rate 4.01, learning rate 4.01, learning rate 1.0, right? And then the next list in the list of lists will be batch size, batch size, some other value, and so forth. And then we're going to take itertools.product of each of those lists in turn. And this is where it gets maybe a little confusing. I'd recommend maybe looking at the documentation. We can talk it out really nice ourselves if we need to. Feel free to ask questions. I know this part's maybe a little tricky, but what all this thing does is it creates a generator that each time we iterate over it, gives us a different combination of things, one thing from this list, one thing from this list, one thing from this list. And it gives us a list, right? So if we turn that generator just keeps giving us new combinations each time we run it until it runs out of combinations that are possible. And so after we generate every single one of those, right, we end up with an array of dictionaries that look like this. Learning rate, one from this list, like I said. Batch size, one from this list, like I said. Activation function, one from this list. So it's just generating every possible combination of those things. And so we'll have a big list of dictionaries, right, that look like this, but with unique combinations from our possible selection. Okay. And then we're going to put it in a data. So go ahead. Sorry.
Is the generator going to, I mean, I understand that it gives you all the possible values, but are they randomly generated? Like could it be like the first item in the list is going to be the 8th value from the first list, 20th value from the second list?
That's a good question. And there's no reason it couldn't be programmed that way, but it does it sequentially. So the first, it'll always be first, then first, second, then first, third, right? And so on, like you would enumerate combinations.
Yeah. Okay.
Yeah. And then we're going to stick it in a data frame and then write the data frame to a CSV, which is going to then be the input to our payload script that I showed you earlier. Right? And I know that it seems like there's a lot of layers here, so you may have to take some time. You can ask questions, whatever. You may take some time to untangle it, but I think this is worth untangling because being able to run a design of experiments on Chiha for hyperparameter optimization and understanding how that works can be really beneficial to your workload. Okay.
Yeah, I mean, so I have seen this thing in biostatistics tools as well, that you might have some parameter where you have to try out 100 combinations. And
oh yeah, it's in a lot of fields. You see this in engineering when you're doing optimization problems. You see this in machine learning for hyperparameter optimization. I mean, it all really just boils down to choosing an optimal setup for your problem to get the best result. I mean, that's what it boils down to, and that's in every field. So,
yeah.
Right. And this just helps us run it on Chiha so we can explore a larger design space and get an even better result than we would if we just did it naively, or if we had fewer computational resources. So we're just taking advantage of the fact that we have thousands of cores and lots of time on Chiha, right?
Yeah.
So this is optimizing our optimization. Yeah. Okay. And so this pretty print just dumps out the file. And so that's just, we'll see it when we run it. So I'm going to go ahead and run it. Of course, we need our own script to run that. And so I have a script that will create another script, right? That's what this boils down to. So let me pull up the terminal. I'm just going to go ahead and batch. Whoops. Batch. Okay. And then that may take a minute. And you'll notice Ravi had the Q and I have S, my jobs. We both have an alias for showing just our jobs. Yeah, it's a nice one. I recommend exploring that in your .batch RC file. If you don't know how, we can answer that question at office hours, or you can look it up online.
And people who are for people who are not familiar, this is basically just SQ-U and your Blazor ID. That's showing you just your jobs that are running on the Chiha cluster. We have just created aliases for ourselves so that we don't have to type the entire thing, and we can just type in one word or one letter over here and get the same result.
There we go. Yep. I'm gonna steal Ravi's though. I like Q better. It's a lot shorter. Okay, so it generated two files. It generated a CSV file and a shell file. I'm going to show you the CSV file first. So hey, look, that's exactly what we expected, right? 0.001, 10. So this is the first parameter from learning rate. The first parameter from batch size. The first parameter from activation. 112, 113, 121, and so on and so forth all the way through all of them. If you have a lot of parameters and a lot of choices for each parameter, of course, this is going to get huge, right? It grows geometrically with the size of your search space. I don't know that we would, if you're going to go back past maybe 1,000 or even 10,000 kind of range, if you're going to go past that, please talk to us. There are probably better ways to do this. Running 1 million jobs on Chiha may be the wrong angle of attack for your problem. So you may end up wasting a lot of time. But if you're in the 1,000-ish job space, then this is probably kind of closer to where you want to be. I know I've done it before myself. So, all right, and then of course we have this DOE.shell, right? This is our shell script. Right? This is the one that we're going to run that will get us what we want. This is the one that has the array 1 to 27, right? There are 27 combinations, 3 times 3 times 3. We're gonna run 4 at a time, right? And this has that Python-U payload that all it does is it's just a wrapper around the script we care to run. And it grabs the current Slurm ID task, which we talked about is 1 through 27, depending on which job is running. And it picks that line out of the CSV, picks that line out of this file, right? And then passes those arguments as a space separated list to this unknown function. That's it, right? It's just like you would do it by hand, but it's doing it for you. So if we do sbatch DOE.shell, right? It submits that job. You can go look at it. And sure enough, there it is, 1 through 27, 4 at a time. So give it just a second for it to actually, you know, Chiha seems to be very busy lately. That's not a bad thing. All right, there we go. We're running 4 now. So I refresh again. Sure enough, we have a whole bunch of log files, right? And that's it. Like I said, it's just show running, reload. Okay. And eventually it'll spit out outputs. Takes a few seconds. Oh no, that's right. It's all it's doing is just writing to these logs. So eventually it'll get to the next batch. Oh no, Chiha's really busy today. Okay, there it goes. Okay. I'm not going to make you sit here and watch all of these, but you get the idea. So there we go. We have a design of experiments generated in Python. I recommend taking some time if you're familiar with Python, maybe poke around the repo, get a good look, see what's going on. It's maybe a little more intricate than I can explain in detail here, but I think I did my best. If you've got questions, we're happy to answer them now. Otherwise, you know, you can shoot me an email. You can come to our office hours and be happy to chat about how you can solve this kind of problem or help facilitate the solving of this kind of problem for you, or any kind of problem.
So William, I saw that you posted your Git repo in the chat.
Sure.
So I guess people, if they want to copy or modify this, the code in this repo for their own needs, they should be able to do so, right?
They can. Depending on the size and scale of their problem, it might be better suited for them to, say, do some Google searching and find something that might be more tailored to their problem. Because really all I'm doing is showing a quick and dirty, well, maybe not quick and dirty, but a quick and dirty way to solve an optimization problem, right, over some search space. There are as many solutions to that problem as there are people solving these problems. So a Google search might find some more robust library that'll handle your search case better. And if you're interested in implementing a solution like that, if you're like, wait a minute, maybe I do want to explore my parameter space, then yeah, come talk to us. You know, we can help you find something that's maybe a little better tailored to what you're looking for. And I think, I don't remember if I put it in the README. Let me check my README. It's been a bit since I've looked at this repo. Give it a second. It's going to load the preview eventually. Maybe not. Oh, there it goes. Okay. Yep. And so I have, so, this is a really simple way. Like I said, this is a simple way of approaching the problem. So if your problemization is optimization in large state space, then there's lots of ways, right? There's black box optimization, there's multi-arm banded Bayesian optimizers, there's genetic optimization, simulated annealing, gradient-based methods, stochastic gradient-based methods, kind of like, if you're solving a machine learning optimization problem. So there's lots and lots and lots of different ways to tackle this. I just wanted to show you a quick and dirty way to say, like, if you have, 100 different parameter combinations. How can I generate those, and then how can I throw them on Chiha to be as efficient as possible? But if you've got a million, maybe one of these solutions will get you to something that's reasonably good, a lot faster than running a million jobs on Chiha. If anybody has any questions, feel free to ask them.
Hi, this is Eric. So
Hey.
First off, I think this is really awesome. I think I haven't really, thought about doing this before, but I also am doing machine learning, deep learning stuff. So this is definitely something I am looking to implement just to explore hyperparameters.
Sure.
But my question is, I see that you guys are running all of these array jobs on the express partition, and I'm sure you're doing it just for the purpose of time and demonstration.
Yeah.
But
we don't want to eat up a lot of Chiha stuff, so resources.
Is there any limitations to running array jobs on particular partitions, or you can do it on any one?
There are no hard limitations, but there are soft ones, right? So if you wanted to run, say, this on GPU, right, you're going to run up against priority pretty quick, because there's only, how many GPUs do we have?
Right we have 72 P100s
72.
and 8 K80s.
Right. So if you end up eating, 18 or 20 of those GPUs, you're going to get run up against priority pretty hard, because there's going to be other people who want to use those GPUs, right? So if you're using 20 GPUs, you're already using nearly a third of the resources, right? So that's a soft limit. Another soft limit would be that we don't allow people to use more than a certain, well, I guess it's a hard limit, but it depends on how many CPUs you use, right? Like Ravi said before, you can only use 300 CPUs at a time, for example. I hope that answers your question.
But other than
you can
that,
choose our partition,
partitions, you should be fine to use any one of them. All the other limits, like William mentioned, all of them still apply. Like you can submit 1,000 cores of one core jobs. You can submit 1,000 of them as array jobs. And if you don't specify any limit using percentage, some number, Slurm is going to create a limit for you anyways after 300. The reason why we were asking you to create that percentage value was so that you don't get into a stage where you don't have any cores available to you. And if you wanted to do anything else on Chiha, you were not able to do that.
Right. Like my overall use case for Chiha, I'm a dual appointment, so I work in facilitation doing this stuff, but I also work directly with ophthalmology, the School of Ophthalmology and the Vision Science Research Center. Right now, I'm running 4 projects that either are or will be using Chiha resources. And so for me, being able to, I might be running 12 GPU jobs for one project. I don't want to run so many that I can't do anything else, right? I need to be able to use Chiha for exploration on the other projects. So for me, the use case would be, I really need to use that % symbol and that number after it, or else I'm going to get in trouble with, well, now, okay, my day's over and it's 10 o'clock in the morning because I started my job and I used up all of my, my priority is so low now I can't do anything. So that's one example. I mean, I'm sure there's plenty of other use cases. Like Robbie talked about too, if you use 300 cores, now you don't have anything left for an interactive job. So if you wanted to, fiddle around with your code or refactor or whatever for the next round, you're out of luck. So that's why you want to play around. You want to take heed on those kinds of things.
Okay, so if I have, let's say, 20 jobs to run, but I only set it to run 4 at a time, then that basically frees up my other resources, right?
Yeah, right. So the more jobs that you have running at a time, the lower your priority goes, or the higher. Worse, it's less good for you.
Okay, that makes sense.
That makes sense. But if you want to run 20 at a time because you won't be doing anything else with Chiha, then go for it. It's fine.
Oh, okay.
Yeah. Yeah. Any other questions? Did that answer your question, Eric?
Yeah, that's
great.
Good answer.
I think if there's, well, I don't want to interrupt anybody, but I will say that the 2 key takeaways here that I would like for people to take away from this is, 1, array jobs are helpful because they keep you from making mistakes with Chiha. One thing is, if you run 1,000 jobs and throw 1,000 separate jobs at Chiha all at once, you could potentially crash the Slurm scheduler. And if that happens, then nobody gets to run any jobs till we fix it. And you might even lose some work that you were in the middle of, potentially. I've seen that happen too. And so array jobs, you can submit 1,000 at once because Slurm only has to keep track of one, the array job overall, and then whatever fraction of those that it's running at a time. It makes it a lot more manageable and digestible for the scheduler. So that's the first thing. The second thing is we're available to help you figure out how to leverage the resources we have to do science faster and to do more science, right? And that's the purpose of what I was showing you here. Is it's great to play with parameters, pick and choose, but if you really want to explore your search space, there are a lot of ways to do it. So if you're running any kind of optimization problem, or you're just like, I have a hunch that somewhere over here with these parameters we might get better results, come to us so we can help you figure that stuff out.
All right. So if nobody else,
I have a question. Yes.
oh yeah, sure. Go
Thank
ahead.
you. First of all, thank you for the tutorial, and I just want to say thanks for the help you're doing. But I don't know. I would say what I see is very helpful. It's going to be very helpful to me on my research. But what would you say? What would you what would you suggest if I didn't know anything? If my guess anything, most of what you say today, what background do I need to take a look at before I start to implement these, especially dealing with the hyperparameters, because I'll be also working on machine learning basics.
You're talking about, are you asking where would I find resources for someone who's a brand new beginner to Chiha?
Yes.
That's a great question. Ravi?
I mean, also for the,
sorry.
I don't know how to also do the, I've never had any, or I have very small experience with Linux commands, so I don't know if I will be.
I mean, that is a good start. Some basics about the Linux, because Chiha, as I'm guessing you all must be familiar with, is running on CentOS, that is a Linux platform. So having some experience with Linux is definitely useful, because that allows you to navigate through the system and have some idea about why you are running the commands, or having the ability to go to a manual for a command and stuff. If you are very new to Chiha, I would suggest go to the Chiha Slurm like I showed earlier. So if you just Google Chiha and Slurm, that's the first link that would show up. I would definitely recommend reading that page, and then Chiha getting started. So just type in Chiha and getting started on Google as well. That should be the first link that shows up.
So this page, right, Ravi?
Yeah, so this is Slurm, and if you just Google for Chiha and getting started, that should be the first link again that shows up. Yes. So go through these two pages. They should be useful for you in creating job scripts. Once you have a bit of familiarity with the job script, that at that point you'll start seeing the advantages that we were mentioning with array jobs, especially when you are going to start working on multiple subjects at the same time. And you initially, if are only going to be 2 or 3, you might just go and copy and create a new job script that way, and just make one change to the copied script. But eventually you'll start seeing where this array job comes into play and how advantageous this could be.
It might also be helpful. I know it's maybe not in your domain, but the Data Science Club channel on YouTube, the first video or two, have some interacting with the terminal and things like that, building Anaconda environments and just interacting with the terminal in general. So that may also be helpful. And those are hosted by Ravi and William Stonewall, who's moved on to other opportunities. But we've been doing, there's a ton of videos in here. So it might be.
Yeah, this would be a good, I guess, channel to subscribe to. We do have videos every week on Data Science Club, apart from the week when we have this user session. And you can get all the previous user session, or at least some of the previous sessions. We have recently started doing it more frequently, getting this thing live. But
right here. We just started, but yes, we've got. There we go. So yeah, we've got 2 here now.
Yeah, and so it would be useful to, I guess, subscribe and see and have these videos available to you guys to
Right.
actually test it out. And data science, we basically go through different data science concepts and machine learning concepts. If you guys are very new to it, fairly new to it, or if you guys just take a look at the intro and see or the title of the video and see if it might be something that you might, or if you wanted to look at that for your future projects or something.
Yeah, I posted those 3 pages into the chat here too. Okay.
Thank you. I'm familiar with the machine learning and data science concept. It's just how to parallelize the work on Jihad. That's what I always worry about. Thank you so much for that.
Sure. And one last thing, if you're a brand new beginner, I've lost count of the number of times we've helped brand new beginners get started in our office hours, and we never get tired of it. So, the more people show up in our office hours and ask for help, the better we look too. So we love helping people in office hours. So if you ever feel like you don't understand something, or you need some assistance, or you're just something just doesn't quite make sense, drop on by. We'd be happy to help you.
Perfect. Thank you. And it's every Wednesday from 1 to 3, or?
Yeah. Let me see if I can. Hold on. Well, it's on the rc.uab.edu main page. So let me log in. I will show you in just a moment. Okay, and this is now the one time I need to have it tell it to send me a push in 30 days. So of course that happens right now. Just 1 second. I'm gonna get to my phone now and press OK. Go figure, right? The one time and the 30-day counter. It's right during this session. Anyway, here. Yeah, so if you go to the rc.uab.edu page and you log in, then right at the top in our banner, we have all of our office hours. And we have the Zoom links and what day and time of the week. Okay? Does that answer your question?
Yes, thank you.
Awesome, great.
And one last thing is, I may have a personal problem in my account. I don't know if I should ask now or should I come to a different source?
Yeah, I mean, so either you can come to the office hours or you can send us an email on support@listserv.uab.edu, and we can work with you through the emails, I guess, whatever is happening in your account.
Will you be holding the office hours today after the meeting? Or?
Well, most probably tomorrow we are going to have our office hours session. Now, generally we try to avoid having office hours on the day we do the user session, just because we don't know how long it's going to last.
Okay, perfect. All right, thank you.
And I tend to lose track of time, so I can go on for a long time.
Thank you.
Sure. Happy to help.
All right. If you guys have any other questions, William already mentioned the office hours in which you can go, and email also. I think he has posted in the chat session. So you guys can email to us if you have any issues as well.
There you go.
All right. Thank you, everyone.
Thanks for being a great audience.
Yep. Thank you guys so much. Have a good day.
You're welcome. You too.